So for non-solids of revolution, finding the cross-sectional area to use in the integral formula is a little harder. So say we have a solid that has the base of the circle x squared plus y squared equals 1. And so we want to know what the volume of the solid will be if the cross-sections are perpendicular to the x-axis and are equilateral triangles. So if you can imagine, we're basically taking triangles and putting them on this circle, perpendicular to the x-axis. And so the triangles are sticking out of the page and making a three-dimensional object. And so this is a sample triangle from the cross-section. And so this part, the midway on the base of the triangle, this is on the x-axis. And so on either side, the length is y. And then, since this is a 30, 60, 90 triangle, this line from the top to the bottom of the triangle will be the square root of 3 times y. And so, well, y in this case is the square root of 1 minus x squared. So we know that the area of this cross-section is just 1/2 times the base times the height. So the base of each of the cross-sections is 2y, and the height is square root of 3y. So then, plugging in square root 1 minus x squared for y, we get that the cross-sectional area of each of these triangles is square root 3 times 1 minus x squared. And so now we have the formula for the area of each cross-section. So all we have to do is integrate it from -1 to 1 with respect to x. And so if we integrate, then we just get 4 square root 3 over 3 as the volume of this solid that we get from putting equilateral triangles on this circle. So what if we have the same base of the solid, but instead of putting triangles on top of it, we put squares on top of it? So the sides of each square, since they go from here to here, the side of a square will be 2y. And so the area of each square cross-section will just be 2y squared. And since y is the square root of 1 minus x squared, the area will just be 4 times 1 minus x squared. So we just integrate this from -1 to 1 with respect to x, and we get the volume is 16 over 3. So basically, you just have to identify which shape the cross-sections are, and then imagine putting them on the base of the solid, and find the area of each cross-section by drawing out the shape and labeling the lengths. You have to identify where does the y value fit in.